Welcome to this little tour de force through how we pulled off porting LibreOffice to WebAssembly, which is what this talk is about. My name, Thorsten Behrens. I'm running a software consultancy mostly focused on LibreOffice, and we have been doing that with that company. Other than that, I'm also the current chairperson of the Document Foundation, which is the foundation actually holding the LibreOffice project and running that, and one of the founders of that project. So you might ask yourself, why did we do that? I mean, it doesn't maybe come naturally, and as it turned out, it also wasn't actually trivial to do that. There's about a ton of reasons. First of all, clearly the browser is where lots of innovation takes place, and also where many people move to these days. So that was clearly something that sounded interesting from a project perspective to explore. There have been other attempts. You all know about Collabora Online as the first working solution there, but there's been other attempts as well. There's been push towards mobile since many years for that code base. And per se, LibreOffice is very portable. I mean, it started as something very portable. It was one of the first cross-platform attempts to run an Office suite back in the 90s when it started with Windows, and then they had something for the old Mac OS, and then they had a Solaris port and a Linux port. So codebase per se is it comes natural to LibreOffice to port things natively. Then there's the problem, of course, with the existing solutions that are there, that if you want something that comes natively to the whole web story, you want something that runs, fully runs locally. So you have all kinds of problems with latency and scalability. And if you want to do end-to-end encryption, which becomes increasingly important these days, you run into challenges that the fundamental solution to that is to run the thing natively. The other bit was that I've been monitoring this whole WebAssembly thing since many years. We had an initial attempt in 2015. I think WebAssembly is something like 8-9 years old now. In 2015 to try that, it was clearly much too early, but it looked like 2 years ago that many things were falling into place. So I said, let's have another try there. Yeah, and then this whole digital sovereignty question, what is there? If you want to, like you're saying, we need some office productivity, or we need to be able to convert something to PDF just like that. And if you want to do that, the solutions that you got are either one of the hyperscalers, which poses problems in its own right. Question whether that's data protection, that you're out of compliance there. Or whether you want to kind of rely on that sort of business for your own critical business or for your own critical infrastructure. So, yeah, a multitude of reasons why we looked into that, and what came along was an opportunity to do that with the NLNet people. I hope that is actually. That is not great. Okay, let me try to very quickly fix that. The slides will not be looking that beautiful, but hopefully at least you can see something there. Looks like the video capture is making the signal quite a bit worse. Yeah, I will try to get something maybe. maybe get some red text or something. So let's see. Is that any better? Okay. Yeah, sorry for that. We look great on my screen. So, right. What came along was the opportunity to get funding from NLNet, who got some chunk of money from this EU Horizon 2020 project. And I was just setting up my own company, so that like were two good reasons to try that. Yeah, so that's a co-investment from EU money, so our money, public money, and some bit of investment from my company to do that. And the goal was ported natively, like no emulation or anything, just classic cross-building, like we run that on iOS, like we run that on Android, natively on that platform. So yes, as you can imagine, there were a few challenges to do that, and let's walk through that. And if you got any questions there, any like why did you do that? Why didn't you instead use solution B there? Or if you have questions like I'm going too fast, we'll get a bit of time today. Feel free to ask. So as I said, we tried that in 2015, and it turns out that the platform itself, platform means like if you port something that's like the entirety like of that stack, that's the compiler, that's like the linker, the tools like bin utils, whatever, and it's also like what you're running on. In this case, that's the browser. That was unclear what the maturity of that platform would be, and it turns out that there were actually quite some snags that we were hitting. There's this line in this joke, this running gag in the project that LibreOffice and before that OpenOffice are breaking your tool since 1990 because it's rather large, rather complex. So we hit all kinds of corner cases everywhere. We were hitting that like when we were porting to Mac. We were hitting that when we were porting to Android, and we also hit it when we were porting to the browser. Yeah, size of the problem. So project is pretty large. It also pulls in lots of third-party libraries. So it's like pretty much at the top of the stack and pulls in half of the library ecosystem for C and C++ that is there. On a Linux desktop, more than 100, I think 120-ish third-party libraries that we pull in. Yeah, and notorious to break. Then the size of the binary was something that we were kind of worried about because we knew what's the size for Android, for example. Of course, we know what's the size for desktop, which is large, like 400, 500 megs, which is just, so we knew it would be too large for the browser. We were hopeful we could kind of pare it down, so by just cutting things out that we don't necessarily need, kind of also try to say, let's just try writer first, like all the other applications, we leave that out. So there was clear from the get-go that we would have, that we were running into size issues. both in terms of like what's running in the browser, like in the sandbox, but also like when it comes to download size, because you really don't want to wait like, I don't know, half an hour for your for initial download to start. And of course, then if it's too large, the browser usually wouldn't cache it, so that you would pay the price like every time you reload the page or you go back there. Yeah, the other bit is like multi-threading. LibreOffice is heavily multi-threaded right now. For writer, that's kind of unnecessary. So we also had the hope that we would be able to kind of work around that, at least for writer. Writer was the very first application that back in the days Star Division was building, and it was like Windows 3.11 times. So that was like, there was no real multi-threading. It was cooperative multitasking. So you were essentially having a single thread, and then if you wanted to do something in parallel, you would have some timer that you would then fire. So you would just repeatedly send yourself a timer event. So we had this hope that we could maybe get around that. And then there's this component framework that LibreOffice is using called UNO. And we said, yeah, we can probably also like get away with not porting that. Because that's kind of like libFFI, if you know that, like that's like really generic, like almost dynamic code generation style. So we say, let's maybe not try that in the first instance. Heap size, yeah, that was not. I mean, we're running and we have 32-bit applications for Windows and Linux still for LibreOffice, so I wasn't too worried about that. Just that probably practically, if we use more than 1 gigabyte in a browser tab, then people would be probably slightly unhappy as well. So that's being efficient and small. That was clearly a concern. Yeah, and last but not least, that was the complete unknown. Like, what's the development and debugging environment going to be? That was clear, that was kind of super fresh, that there was like almost, when we started, there was nothing. So there was no way to debug that like you would be used to, like with GDB or with Visual Studio, like having source level debugging, being able to set breakpoints. Like there was nothing when we started. So right now where we are is we got when we pack it, like when we hit it hard with the Broadly compressor, we get it down to 35 megs for the writer-only thing. But if we don't, or if we have debug symbols, then it's like 200 megs and about a gigabyte of symbols. We also need lots of kind of beyond the actual code. We need lots of auxiliary files like config, like fonts, like the UI definition. There's some like Glade UI files there. That sums up to about 100 megs all in all, and we also need that to run in a browser. So we were kind of worried how to do that. Yeah, so that's kind of a bit of a half house right now. So we kind of split that down, or we pared that down as well, and we pack that. And it could be something we could keep locally because it doesn't really change much. We could also try web fonts. So that's all. But in this corner of size issues. And it also turned out to be a problem with actually generating that. So that's more like on the breaking your tool chain side. Yes, and then of course, what's the point in having that if you can't really use that? If the only thing that you can do is having this little demo that I'm going to show later. So you won't really have it somehow embeddable. You want to have an iframe. You want to have some HTML widget that you can actually use this thing in your web application. So that there's very little point in having just a text editor in a web page, because where's the data coming from? Like where are you going to put the data when it comes out? If you want to end-to-end encrypt that, like what are you going to do with it? So having this embeddable and programmable, there was another question how to do that. Because the way LibreOffice does that on the desktop, or also for Collabora Online, or in general also for the mobile, like the Android version, also kind of uses this API, this very, very powerful, also very complex programmability interface from LibreOffice. And when we started, I didn't have really a good plan how to move that into something that we can use from JavaScript. So that's a bit of a spoiler, and so that we keep you engaged, so that you know what's coming there. So where we are now is on LibreOffice master repository. You can actually build that and run that. So there's some README there. When you check out the code, under static README WASM, there is some how to set your development environment up. And after you did that, which is not much more difficult than setting it up for any other LibreOffice platform, which is also a little bit involved in terms of what you need to install there. But if you did that and you built that or on master, then you get something that you can actually run, and then you get a writer in your local browser. You can also go for the feature branch there that I list there, where we're a little bit further on. It's a bit more experimental. A few more things ongoing there, which I will get to later in this talk. So that's pretty much the status. So we actually pulled it off. It's still like a million things to do, but we actually managed. And how we managed that, I will get into now. So when we started in October 2020, and we relatively quickly managed to get the initial setup going, like this cross-build environment. Like we went for emscripten. That was clear from the get-go. That was the tool of choice, and we managed to get like the configure to pass and the first libraries to build in a cross-build setup. As I said, LibreOffice per se is already pretty well equipped to do that. It's an auto tools project, and we are already cross-built for a number of platforms. So what we also did, we set up some Docker images to make building a bit easier, because it's kind of complex to set up, and it's also kind of brittle. So it's not that you set up, you follow the how to the dot, and you set it up today, and you do the same on another machine the next week, and you get a slightly different setup, which is a bit of a problem also to support people there. So I think the image-based approach is the best one, like for people who want to get their feet wet and try that, because that's something that's guaranteed to work. Like, you pull the image, you set up your build environment, it's gonna work. If you do it manually, first of all, it takes more time, and it also not guaranteed to be exactly the same. So that was like end of 2020. We got that pretty much going, and then it took another year to get the first actual things moving in the browser. And why that was so massively problematic, I will tell you. And it was actually a death march. So there was like, it was at some stage, it wasn't clear if we would manage to pull it off, like in terms of trusting ourselves, and then also in terms of funding, because there was like finite number of euros that we could spend on that. And also the company was like pretty fresh, so it wasn't quite clear that we would manage in the end, but we did it. and we did get Writer practically working. So the October 2021, there was some little demo, like LibreOffice has some own GUI library, and there's a little demo application for that, and we made it work in October. And after that, it was relatively, in comparison, relatively easy to get actually Writer opening and doing something useful. And that was for FrOSCon this year that we managed that. So we had this very first announcement that, hey, look, it's actually working at FrOSCon this year. So what's ongoing is actually get calc working, and then we thought that the other two bits that are interesting is headless document conversion, in particular getting PDF conversion going, so that's kind of nice for something like CryptPad, for example. If you get something end-to-end encrypted, and then you just want a bloody PDF, and so what are you going to do? I mean, it's an Office document there that you're editing, or you need to convert something into something that is like more friendly to your platform, but it's also end-to-end encrypted. So kind of sending that to some conversion service on a server kind of breaks that confidentiality. So having something headless, like you just pull in a library and you do that in your browser instance locally with your local data, and the data that never leaves your device, that could be nice. And as I said, this whole JavaScript framework connector, having some demo code like for like 1 or 2 or 3 popular frameworks up there, that would also be nice to have. We started with that for Vue.js, but it's like kind of, I wouldn't even call it a demo. It's more like a proof of concept. So yeah, actually you click this button and then something happens. So it's like technically we know how to do that, and now we need to kind of flesh it out and do it nice. And that's to do. So then how did we approach? So when you start something like this, there's just so many unknowns. You need to make some calls when you start. And then you need to try to stick to those calls, and not like, oh, I tried it for a week, it didn't work, and then you try another thing, and then another thing, and then another thing. So we were pretty confident with the choices we made, and those were those choices. We were not willing to go and change the build system for LibreOffice, because that would mean that we would like constantly in catch-up mode, because the upstream project does it with auto tools and this GNU Make, and if you have a parallel build system, you're constantly like trying to catch up. Somebody changes something, they don't care about your little build system there on the side, so it's pretty much always broken on master. So we said we stick with that, and try to like build on top, because it was already like cross-building was already well supported. Then LibreOffice has its own GUI abstraction, so it's pretty much like Firefox, that there is a little GUI toolkit, which is conceptually very similar to Qt. So it's cross-platform. So it's like you render the GUI, but the logic, the feel of that, like how the controls interact with each other, that's kind of local to LibreOffice. And we have plugins for GTK, we have plugins for Qt, Windows 32, the old Windows API and OS X. And we also didn't want to touch that. There were like, in 30 years, nobody managed to change that, so we're clearly not willing to do that. And as it turns out, with this Qt plugin, so it's essentially using Qt widgets to render the stuff, but like, as I said, the GUI logic, like when you press tab, what's going to happen, that's still, that code is still in LibreOffice. So with the Qt plugin that already has WebAssembly support natively, And from the demos that we were looking at, that did look quite nice. Like we thought, that could work. Like that looks pretty mature. So we went with that. Of course, we hit like, I don't know, 50 problems there. But we were kind of, that was to be expected. Then that's kind of a truism. LibreOffice is basically C++, and pretty modern right now. Many things, we don't use all C++ 17 features because we always have to use the intersection. Like we have like 4 or 5 compiler platforms, and we can only use what they all kind of support. So there's a number of features we can't quite use yet for C++ 17, but it's pretty modern C++ by any means. So we kind of choose emscripten. There's a number of other cross-build, C++ cross-building projects, but emscripten looked like where most of the momentum was, and with the biggest, with the best support. And we pinned that to one specific version because it turns out to be very, very, very in flux. Like you update and nothing works, and then you update again, and oh, look, a new feature suddenly works, or an old bug goes away. So just to keep that noise a bit down, we pinned that to that version earlier this year. Yeah, and we really don't want to use anything that's experimental. That's actually not something that we said in the beginning, but that's something we learned the hard way. So yeah, that platform, like lots of things moving, and like don't use anything that's experimental. Like really don't. It's gonna be painful. So no threading if possible, no dynamic linking, no native WASM exceptions. So using just the emulated C++ exceptions there. Yes, and those choices, like they cause quite some problems, but I think the cure would have been worse than the disease. Like trying to, because that would have meant that we would probably have been fixing the platform, like fixing emscripten or working there, and that we were not really up to do that. Yeah, and we wanted to focus on writer, just to be able to cut other things out, and yeah, just the number of third-party libraries that writer pulls in is a subset. Writer is the oldest application, so we were hoping like, we can maybe get away with a single-threaded there. But it was mostly the reason for size. So what problems did we hit? emscripten and browser tools. Yeah, that was the most disastrous. No, that was one of the two disaster areas. As it turns out, when we started in 2020, many things didn't really work so well. There was no source level debugging. There was this problem with this Heartbleed and other exploits where browser vendors decided that the shared array buffer would probably be best disabled. Because you had this like hammer the memory, and then you can figure out, due to caching issues, like what's in the area that you're not supposed to read, and kind of figure out what's there. And quite unstable, like especially Firefox was really had some stability issues there. And as I said, this SDK, emscripten SDK setup was kind of brittle. To set this up, and we wasted quite some time. Like, I don't see, so we were like team of 3, and I don't see your problem. Yeah, but I can reproduce it locally, and it turns out it was not like, the reason was that the emscripten setup was different, and you can waste a lot of time trying to chase those sort of ghosts. The other bit was that LibreOffice, there has a kind of, the build system there is nominally GNU-make, but it's essentially almost Lisp level functional programming language on top, like with this eval and call, very, very dynamic. extremely powerful, but also really hard to debug and to extend. And the challenge was we actually had to extend it because static linking was something that was not natively supported. There was a hack for Android where we're just using a parallel build system just to shove it all into one Android binary. And as I said, that's something that we really didn't want to, like having a parallel build system. And also it was sufficiently due to the fact that we were kind of only building part of LibreOffice and we really wanted to only link that apart. Like we didn't want to link it all, but what's the point in stripping it down and then just linking everything? So yeah, we had to implement that. And that turned out to be quite massive, 88 commits, more than 4,000 lines of code in a pretty complex system, so that took like half a year to pull that off. And it also triggered a number of problems that we were not aware of from the start, like dependency loops, because LibreOffice with this component system has this dependency inversion, so you want something like so you have a service string and you go to the factory and that gets you something, and that's like runtime evaluated, and when you start to link that statically, then you have to declare a dependency, like I want the service during link time, but the service actually uses my own library, so you have this dependency loop there, and we had to break that. Yeah, and also we had to make that actually known, like that the UNOS, like for desktop, that dependency gets resolved during runtime. But of course, you need to resolve it during link time if you link statically. So we had to actually implement this as a static dependency, and it was also causing some headaches there and some work. Yeah, that's what I just said. The UNO components. So we had to switch that to static dependency. Then the secondary files that we need during runtime, where we had to build some virtual embedded file system image, where there was no support in 2020 when we started. And we got lucky, like in very many ways, that as the project evolved and as it took us such a long time to do this gbuild extensions, actually the platform evolved, emscripten evolved, and quite a lot. So it turns out that very luckily in the end, we had this perfect moment, like we kind of evolved in lockstep with the platform. As we got things going on our side, the platform fixed problems that we had initially, which were substantial. That held us back probably half a year. At the bottom of the page, the link time when we started was there was some O square problem that link time grew quadratically with the number of symbols, which nobody noticed before because nobody threw something like LibreOffice at this at that platform. But we felt it hard, so at some stage linking took more than an hour and more than 64 gigabyte just to do the linking. So that's not a way you develop. So if every iteration, like any change in the code, takes you an hour plus, and you don't have any source level debugging. So if you want to debug something, you actually got to change this kind of printf debugging essentially. So your turnaround is like in an 8-hour or 10-hour stay, you got maybe 5 or 6 experiments. While when you have a proper debugger, you have this turnaround, like you can do 5 or 6 experiments like in a minute or two. So that the slowdown from that was just where we could just plotting like, okay, so at that speed, how long is it going to take us? And we said like, I don't know, 2 years, 3 years, 4 years. Is this viable? So yeah, and more fun of that kind. Like, for example, optimizer just going belly up. Like we thought like, yeah, maybe optimizer, and that's going to throw out some symbols because it's just linking what it's like. It's a bit more aggressive and throwing out stuff, unused code. but it would never complete. So there would be like an infinite loop essentially, or so slow that it would be essentially the same, like an infinite loop. But as I said, that evolved over time. So at some stage, the linking problem went away. At some stage, there was support for separate debug info. At some stage, there was support for source level debugging. So yeah, we were very lucky. So what we did kind of to kill the time, while we were not quite sure what to do there, we went for a little diversion. So as it became clear that we can't work natively on the platform, while we were kind of still trying to make it work, strip it down, make it compile and link successfully in the end, and also get the size down, we said, why not do that natively? Why not do that on Linux? Because essentially what we need in the end is like just this static linking, but the platform really doesn't matter. So why not do that on Linux natively? So now LibreOffice pretty much as a bonus got a way to build all of LibreOffice into one static library. Because with that way we could use the native Linux tools like the debugger and the linker that actually works and terminates. So that's how we managed to make progress while waiting for the platform to evolve. And also it enabled us to fix a number of bugs because we just changed the code and lots of assumptions with this dynamic, like the UNO component system and the runtime dependency resolution. There were lots of assumptions that were just not valid anymore in the static case, so we could debug that and fix that natively on Linux. So yeah, we got that to work. That's something that other platforms can now use, like Android and iOS. That's not something that we are currently working on, but we could. So all that said, in the end, we pulled it off. We managed. We got a bit lucky in a number of ways. On the other hand, you could say that given that that's the way where everyone goes, so it was, in hindsight, it was a bit of a safe bet, I think, because you know, with so many people pouring into that platform, with so many projects, like for example, the trigger for me was that AutoCAD decided to port their own in-house closed source large C++ application to WebAssembly. And there was a talk, I think, in 2018 or 2019 when they did that. We don't have that sort of resources, but it was like, okay, if they pull that off with that application and it works and they run that in production, it's probably something we can do as well in general. And then there's this flywheel effect, like lots of interest, lots of people doing that, and then there's always like, okay, I pay this guy to fix the bug because I really need that. Or browser vendors kind of in competition with each other and making it better here and then better there and better here. So the fact that there is momentum and that there's so much investment in that area made it a relatively safe bet, because obviously you can't work productively if you can't do debugging like you can do debugging for your native code. So yeah, I think it was not in the end that much of a risk. The only risk was really like, will it be there in time before we run out of time or money or energy? It turns out it did work. So then let me just see if I can pull the demo off. That's actually the repository. I have a build here, and the way for doing that is you need to get this environment set up. So it's a bit like virtualenv in Python. So you set up your emscripten SDK here, and then you can run some Well, actually, I have a little note here, so let me paste from my script. So that's a local server that starts a browser and serves this that you see there at the end, this cute SOffice HTML thing to that browser. So let's fire that up. That's using Chrome as a Flatpak because reasons. And let's reload that. So it's actually pretty fast. Once you have it locally, it's like, I think it's faster startup than the native application. So that's Writer now. And why we're using Chrome is that the debugging, if you want to do source level debugging, that's pretty much the only chance you got. So yeah, I don't know if that is visible, but you can actually set breakpoints. You have this entire source tree here, and the breakpoint even gets set when you reload. So you crash somewhere, and then you say, okay, I need a breakpoint like 5 minutes earlier. You set the breakpoint, you reload, and you actually hit the breakpoint. So that's almost what we're used to for regular LibreOffice hacking. And the way to pull this off is like install a Chrome extension, enable some experimental feature, do a bit of magic with the where it pulls the source files from, and then you're good. And that's pretty much best of breed. So Firefox is still like catching up there. When we started, they started to have that sort of support, but they had some internal limits, about 1 million lines of code, when it would just go belly up and say, that's too large. I'm not doing that.
So that's proprietary information for debugging for Chrome, right? Or how does it work with source notes for Chrome? The emscripten patches.
That has some. No, that's so well. Chrome obviously, that's proprietary. Sorry.
Does that use GDB information or not? Regular debugging information.
Yes, that's debugger. So it pulls. Maybe that is visible. Maybe I don't know if you can see that, but it pulls some dwarf, which is a debug format. It pulls that. So that's one of the build artifacts. It pulls that from localhost, and then resolves the symbols. So that's about 1.5 gigabyte, and that kind of works. Yes, and well, you can actually do something here. So you can use this. You can use the sidebar, and you can make it bold, and so it's essentially. So what you see here is essentially the cute GUI, complete with window management and all of that, which is nice for a demo. Which is obviously not what you need when you want to like. What you want is like essentially just the document and maybe the sidebar and all the GUI around that and all the dialects. You want to have that natively in your JavaScript framework of choice. And that's something that we're still working on. As I said, there's some very early stage, like technical proof of concept. Okay, we can make this work. We press a button in Vue.js, and then something happens in LibreOffice. But it's like, yeah, it's not, I wouldn't even say. So if you're interested, maybe we can sit down at the LibreOffice booth and we can talk about that, but it's like not really ready for prime time. Okay, so that's Writer. If now we want to do something that you haven't seen before, I'm not sure if that's probably not visible. So that's one of the source files, and I can just, it's called soffice.js. That's one of the bootstrap things here, and I can just I can change which document it loads. Which is a calc document, and then let's see if, given that this is a demo, in which interesting ways it's going to break. So let's load again. Okay. Well, you get useful debug output here. I think I mistyped. I mistyped. So that's nice. So actually you get what you usually get on the terminal output. You get that in the browser console, which is very useful. So let's try it again. Yeah, even there's calc. Okay, and that's so that's a very very lame document. But same story like with Rider. You can have like the full, like the entire calc formula engine is there. You can have like nice charts, even 3D. Let's maybe try that. Bit of a chart here. Let's cook up some numbers. And add a chart. And for maximum effect, let's make it 3D. And there you go. So yeah. The good thing is that that looks quite impressive, but the moment you get the basic thing working, then you get lots of stuff for free because, well, it's all cross-platform already, like all this 3D stuff that's like just LibreOffice doing software rendering there. So yeah, but I think it's quite nice, like with the Outlook, being able to have that sort of power in your browser, not having to rely on something on some remote server that you don't control, and or having to rely on some hyperscaler that might change the business model any day, and that might run you into trouble because it's running in some jurisdiction that is not exactly compatible to yours, etc., etc. So, yeah, I think it's good to have that. It's still quite some way to go, and it's also quite late in the day, so to just have some moment of questions. I think I said most of that. The slides will be online. I think the video, I don't know what's the plan, but there will also be a video at some stage of this. So Chrome debug setup, that's on the slides. Like you need to install some experimental extension, then you need to enable experimental WebAssembly debugging, then you need to tweak a little bit the path so that this, because at least for the Linux setup, it's a sandbox, so it can't access your files, which is a feature, but this local debug server can actually serve them, so you kind of tweak the path a bit so that this emrun server serves your source files as well, and then you're happy. Remaining problems. Yeah, the problem, of course, with JavaScript in a browser is that there's no, well, you shouldn't be like busy looping. And there's also no good way to have nested main loops. Like you have a main loop, there's an event, it opens a dialog that recursively calls the main loop, which processes events, which opens another dialog, which recursively calls into the main loop to process events. So that's not going to fly in a browser. The problem is that LibreOffice is essentially doing that since I don't know, 30 years. So we need to fix that. The good thing is that there's another project that also needs that fix, which is Collabora Online, because they also have a problem there. And yeah, it's just the size of the problem. It's something like 250-ish dialogues that need to be made asynchronous so that you can fire up the dialogue, then return from your call stack, run in the main loop again, and then if an event happens, like get back into the dialogue code, and so you need to kind of have this asynchronous store your state, have it at the side, not on the stack, and process that, which is kind of well understood. It just needs working, and it's a lot of work because it's a lot of dialogues. There's some way to trigger that hard. So when you set this environment variable and run it, then you will crash hard when you have this nested event loop. So it's good to find the places then. And there are some sample commits where we did that. There's some easy hack if you're interested. I would say it's not that easy, but it's probably also not that hard. So it's something that you can do in like half a day if you look at the sample and if you have your setup going there. Qt backend, yeah, as I said, it was kind of irritatingly bad quality, so we had to fork that and patch that. Qt 6 could be interesting, but it also needs porting LibreOffice to that first. The other alternatives are kind of lots of work as well. At some stage, having something WASM native, especially if you really don't need that much UI, because all your UI is JavaScript, could be interesting. Yeah, and that, yeah, moonshots, the dynamic loading could be interesting because it cuts down on size. You only pay what you need, like makes the first start much faster, but it's experimental. I wouldn't do that. I mentioned that, like the three areas like GUI and embedding, headless conversion, and calc, which is kind of early days. So that needs a bit of work there, but it's probably furthest along. And that's our vision, where we like to place that. So there's one thing that we really can't do that well, which is collaborative editing, because that's a bloody hard problem with a code base that was never meant to do that. So that's easy for, or relatively easy for Collabora Online, because it's one document. You just need to process the events in the right order, and it's just, there's one single source of truth there. If you have that distributed, like 5 documents or 10 documents, and then you need to sync the state, that's going to be quite a bit harder. But it's clearly something that at some stage I would want to look into, but not right now. So that's more like something like this headless conversion, or if that's something where you don't need collaborative editing, but you need the other feature like end-to-end encryption or offline capability, or any of the advantages that are listed. And there's a little demo if you want to play with that. Yeah, depending on how many of you hit that today, it might be a bit slow, so be patient, but it should serve your writer and the demo document. And that's it. And let's open for some questions and hopefully answers. Should we have some microphone maybe for the audience, or if there's any questions at all? Should I come up with questions myself? Like, when is it done? Yeah, there's one question over here. Let me quickly do that one.
So you were talking about experimental or new WASM features, so multi-threading and exception handling, I think I saw. And another pretty recent WASM feature was like proper SIMD. In the demo I saw the interface was semi-slow, which is to be expected. We're going through multiple layers there, and it's still always going to be like a factor of 2 times or something like that slower than native. So do you have any ideas or plans about how to integrate SIMD, or does that entirely depend on the compilers?
Yeah, so yeah, that would be something that we would. So I'm not saying we're not going to look into that. It's just like right now there's just a very long list of very like make or break things. Like if it crashes after 2 minutes, we got to fix that first. And then like speed is actually not bad. So it's like on a desktop, it's like there's virtually no difference between a native. Well, I'm sure there is a difference, but there's no noticeable difference. Like the GUI is like snappy and like I'm sure that if you load a large document, there's going to be a difference. But like that's not like very high up on the list of priorities that we have. Like speed is not once we get caching. Like once the WASM bits are cached locally, which is kind of either you tweak your browser settings or you get it small enough so that it would cache it. It starts like in 2-3 seconds. So and the like when you interact with the document, that's actually quite fast. So yeah, not. But of course, like any wins that comes for free, like anything that, and I do expect quite a bit there because trying to push that closer to native speed, that's clearly something that many people would be interested in. So that's probably going to happen by just waiting it out a bit.
So you said the project kickoff was in October 2020, and I guess you said like 3 people were working on this. So my question is actually, how many man-hours did you already spend on getting to this point you just presented?
I'm not going to tell you because it's quite depressing. Yeah, but it was substantial. So it was not like in terms of person years. So it was like it wasn't 5 person years, but it was probably on the order of close to a person year that we spent. So we didn't. So we were working with 3 people on that, but not full time 3 people all the time. I still had somehow run a company and get the money in from other sides. Okay. Maybe one last question. I think we're at the end of the hour.
What's the main purpose in the end of this application? What do we want to do with it if it's not replacing Collabora and the desktop editors?
Yeah, so as I said, the focus is something, so we're very strong with that idea in an area where others are not so very strong and vice versa. So I think the strongest, the most interest I'm getting is this headless conversion. That is clearly something where there is a need for PDF or for document conversion, like from docx to ODS, ODF, and or the other way around. Or some obscure formats like, I don't know, AppleWorks or stuff like that. And the other bit is having something like a way to have rich text editing or a calc formula engine right there in your larger application. So we have a line of business application. There's about, I don't know how many million line of business applications that are right now running on the desktop. And they kind of plug Microsoft Office or LibreOffice or something else because people really want to edit their letter. It's kind of pre-filled, but they want to like put the nice finishing touch on that. Or you have some spreadsheet where you do some calculations and you want to be able to do that right there in your whatever. You're running a business, you're running a doctor's office, your kind of production side or something, and there's lots and lots of specialty software that does that. And they're all moving into the web. Like they have been desktop based for the last 30 years, and they're now moving into the web, into the browser, and there's clearly a need for that because it's just easier to do, and you don't need any collaboration features for that. You just need the way to hand over the document, edit it, and then kind of store it in a document management system, or send it out, or download it, or what else, or print it. Okay, I think we're out of time. Thanks so much. See you around. Have a good FrOSCon.